So in order to solve this, I've got a fraction minus a fraction. My primary school teacher told me that the denominators have to be the same. The denominator, we will take the LCM. Instead of simply take 3 times 12, which is 36, too big. I would rather take 3 times 4, and the entire numerator times 4. So this simplifies. This gives me 4 times of x minus 7, then minus, okay, in the denominator it is 12. Now, what should I write? What should I write over here to complete it? Should I just write x minus 5? Like this? X minus 5? Is this correct? For the fraction on the left. This is this entire portion equal to this entire portion. Are they the same? Yes or no? Same or not same? Who thinks that they are not the same? Raise your hand. If you think they're not the same, you raise your hand. I won't call you. I won't ask you to explain. I won't. I want to know who thinks that these two highlighted portions are not the same. Raise your hand. Okay, who thinks that they are the same? Raise your hand. Same? If they are the same, raise your hand. Okay, who thinks that you don't know? You don't know why Mr. Wong asking this question. Okay. Put your hands. Let me illustrate with an example, with numbers this time. 1 over 12 minus 7 minus 5 over 12. Okay. How would you do this question? If it is a primary school question, what would you do first? 7 minus 5, right? Okay. Wait, 1 over 12 minus 7 minus 5, that is 2 over 12. Right?
Yeah.
What would you continue to do? Fraction minus fraction.
1
1 minus
minus 2.
2, because the denominators are not the same. And you get negative 1 over 12, right?
Yeah.
Okay. How certain are you that this is the correct answer? How certain are you?
100.
100%? Not at all. Why not, Glenn? Which part are you unsure of? Then something needs to change if you're never confident. But you're pretty confident in saying that you're not confident though. Okay, so we are sure that this is the correct answer. But how does this relate to what I have highlighted on the left hand side?
Because the bracket, the x.
Okay, hang on first. The first fraction on the left, I'm just replacing with 1 over 12. Then I've got a minus sign. I've got a number. In this case, it is x. In my case, it is 7 minus 5 over 12. Okay? So, keeping in mind that negative 1 over 12 is the correct answer. What I have done in the next step over here is to say that this is equivalent to 1 over 12. Okay, I copy down the first numerator. Minus 7 minus 5. I am saying that, hey, this is supposed to be correct. At first glance, yeah, it looks fine. 1 minus 7 minus 5 over 12. Same denominator. Yeah, I think I can do that. Let's see what we get in the numerator. 1 minus 7 is negative 6. Negative 6 minus 5 is? Negative 11 over 12. Oh no, look, are they the same?
No.
If they are not the same, one of them must be wrong, isn't it?
Yeah.
Since I'm really sure that this is correct, then I'm sure that this is now wrong. So what went wrong? Why didn't I get negative 1? Why did I get negative 11?
Because you minus 7 then minus 5. But this one is you minus 7 minus 5. So 7 is positive.
You understand what he's saying? Who understands what he's saying? Some okay? Who don't understand what he's saying? Don't understand, right? Okay, reason is because he didn't talk about brackets. When he say one is minus 7 minus 5, the other is minus 7 minus 5. Sounds like the same thing. What he meant is that, hey, this negative sign, we are actually subtracting the entire numerator. The entire numerator is 7 minus 5. So we are effectively subtracting 2. We are subtracting 2. Whereas in the example below, the way I wrote it, it is 1 minus 7, And then I simply copy down the minus 5 down. I did not take 1 minus 2. Instead, I took 1 minus 12. I was supposed to take 1 minus 2. Instead, I took 1 minus 12. Why did that happen? Because this negative sign was not given to this negative 5. Okay, when we expand it, we get negative times negative gives me positive. This should have been positive. Now, if it is positive, I have 1 minus 7, which is negative 6, then plus 5. That gives me negative 1. And now it will be correct. So the lesson over here is actually the same lesson from 2 weeks ago that I've been telling you. Put brackets over here. You put brackets over the numerator. The entire numerator, we are actually subtracting the entire x minus 5. And then you will be safe. So here, we should have a bracket. Now it is correct. So earlier on, it was wrong. Okay? So if you are doing your corrections, if you are not sure how to do it, please make sure you copy down the correct answers, the correct working. So this is supposed to be 4 times of x minus 7 minus away the entire x minus 5. Not just minus x and then copy down minus 5. No, you need to minus the entire numerator. And the effect of that is that we will have negative times negative to give us positive 5 instead of just copying down a negative 5. So this is what happens on my left hand side. This is equal to the right hand side, 2x minus 27 over 15. Okay, so let us expand the numerator on the left hand side. 4x minus 28 minus x plus 5 over 12 equals to 2x minus 27 over 15. And then I'm really thinking, okay, I've got a fraction equal to another fraction. Eventually, I am going to be doing this. I hope you know what this means by now. Okay, one numerator times the denominator equals to the other numerator times the other denominator. It's the same. But in order to do that, let us ensure that this is simplified further. I don't want to take 15 times 4x, then 15 times 28, 15 times x, 15 times 5. I would rather 4x minus x to give me 3x first. 3x, negative 28 plus 5, negative 23 over 12. And now this is equal to 2x minus 27 over 15. I would rather multiply over here. So I only have 15 multiplied by 3x minus 23 as compared to 15 multiplied by 4 terms. Less room for error this way. Okay, so let's do the multiplication. 15 times of 3x minus 23 is the same as 12 times of 2x minus 27. They are the same. Okay, so if you have been paying attention, the next step would be to expand, right? But can you foresee, can you tell the future, if I were to expand, the numbers are going to get quite big, isn't it? The coefficients are going to get quite big. Is there a way for me to avoid that from happening, although it is not wrong? Instead of just expanding at this stage, is there something that we can do to make our own lives easier?
I know.
Plus 23. Why plus 23? This is actually 15 times of negative 23. You cannot just plus 123 over here. I give you a clue. You all don't say anything yet. Just think by yourself. I give you a clue. 15 and 12. Is there a way for us to make these two numbers smaller by doing one thing on one side and you must do the same thing on the other side so that they remain equal? Because I really hate to take 15 times 23. I wish it was a smaller number. I hate to take 12 times 27. I wish it was a smaller number. Okay, you have some time to think about it already. What would you like to do to the 15 and the 12? What would you like to do? Divide by 3. If I divide by 3 on the left hand side, 15 becomes 5, right? 5 is more manageable. But can I just divide by 3 on the left hand side? I need to divide by 3 on the right hand side. Oh, happy. 12 becomes 4. 4 times 27, manageable. Okay, so that is our plan. Divide lah. So divide and we're left with 5, divide you're left with 4. Now you expand. So 15x minus 23 times 5, 115. And that gives me 8x.
Minus 108.
108. Okay. And now we simplify. Okay. Group all the x terms together by subtracting 8x on both sides, leaving me with 7x. So here I skipped a step. By my mind, I know what I'm doing. I'm subtracting 7x on both 8x on both sides, leaving me with just 7x on the left hand side. And now I want to remove the negative 115. I will have to add 115 to both sides. So adding 115 to the right hand side, 115 minus 108 is 7. So x equals to 1.
Yeah. So you're just doing a lot of fun.
Sorry?
So they were just losing a lot of fun.
Losing a lot of what?
Fun.
What is it? I don't understand.
They're losing a lot of fun.
It's funds. Don't know. Okay, next. Sorry, I couldn't quite catch what you were saying. So instead of dividing by 3, what if I left it as 15 and 12? You still get the same answer. It's just that you're working you have very big coefficients. Okay? You will still get the same answer as long as you are careful. So next one. Exercise 3. This was also your homework. Given the formula. Do you know what formula this is? Temperature. What do you think the C stands for? Celsius. What about the F? Fahrenheit. Yeah. I think this is the formula for conversion from Fahrenheit to Celsius. I think, I'm not sure. It looks like that way. Okay, so let's start with this. Find the value of F. That means find this. When C is equal to 35. So we're going to put in 35 over here. Let's get down to it. 35 equals to 5 over 9 F minus 32. I want to find the value of F. So I do so by getting rid of this 5 over 9. How do I get rid of a coefficient of 5 over 9? Times 9 divided by 5. Yes, correct. Yeah, we can times 9 divided by 5. Alternatively, we can just divide by 5 over 9. Okay? So go ahead and multiply by 9 divided by 5. Alternatively, you take 35 and you divide by 5 over 9. So look at the way that I'm writing it. I deliberately wrote the horizontal line under the 35 longer, because I want to show that I am dividing by the entire 5 over 9. You can use your calculator to work this out. You can change this to become multiplied by 9 over 5, which is the same as what your friend said. So this is equal to F minus 32. Okay? So me being lazy, I'll just do the division divided by 5 over 9. And I get 63. Equals to F minus 32. So I want to find the value of F. I will need to add 32 to both sides. So F will be equal to, adding 32 will be 95. Okay, and this is our answer. Any other suggestions on how we can do this? I don't think everybody did the same steps. If somebody can give me an alternative to this, I will bring something for you next lesson. Yes. What else can we do? Would you do this method? Okay, what would you do? No, wait. Are you going to have this step? Then what is your second step? Yeah lah, 35 divided by 5 over 9, same one. No, your presentation is slightly different. Okay, but essentially it's the same thing. Okay, any other approaches to doing this? Yes?
I'm thinking on it, instead of dividing, you can
Multiply what?
Whole thing from scratch.
Okay, that's the same thing.
How? Anybody else? Any other approach? Don't have ah? Don't be shy. Any other approach? Got price eh? The second step is I'm looking for something else that is different. A different second step.
Instead of 35 divided by 5 over 9, you can do f minus 32 times 9 divided by 5.
Okay, it's the same thing. It's still the same thing. Anybody? No. Then I'm going to show you already, huh? Sure? Okay, so what else can we do? Would you consider this? Can this be done? Do you know how to do this? No, that's not what you said. You said f minus 32 times 9 over 5. This is times 5 over 9. Right? Different. Can we do this? Yeah, we can. Let's see what happens. So, on the left hand side, we still have our 35. On the right hand side, 5 over 9f. 5 over 9f. Then we have minus 32 times 5. That is 160 over 9. Okay, I've only expanded the right hand side. And then I only want f, right? So I want to get rid of this negative 160 over 9. I do so by adding 160 over 9 to both sides. So 35 plus 160 over 9 equals to 5 over 9f. And now I can use my calculator to figure out what is on the left hand side. 35 plus 160 divided by 9. And I get 475 over 9 equals to 5 over 9f. Very ugly numbers. Very uncomfortable when you see these things. But don't worry, trust in your method. Okay, so now I only want f. What must I do to both sides? Divide by 5 over 9. Same thing. It's like I have 3 times 3 apples equals to $12. 1 apple equals to, just divide by the 3 lah. So here I got 5 over 9f. I only want f, so you divide by the 5 over 9. So 475 over 9. Entire fraction divided by another 5 over 9. And this is going to be equal to f. Let me check. So 4, okay, I can't really see on my calculator. So this will be divided by 5 over 9. And I still get 95. So 2 different methods. Trust in what you have learned already. You know, you have learned how to expand this way. What? Some of you, your instincts when you see this might be, I want to expand, I want to get rid of all the brackets. Sure, go ahead. You would still get the same answer if you did it correctly. Okay? So now let's move on for part B. Part B, we've got another formula. Do you recognize it? Anybody recognizes this formula? E equals to half mv square. Energy? Yeah. And have you all learned energy? Not yet. Okay, so this is our kinetic energy. Energy equals to half times the mass times the velocity square. You learn velocity? Yes, I'm sure you learn velocity. How can we know? Oh, really? Okay. Okay, so now half mv square. Do the substitution. Hey, E becomes 160 equals to half m. M. Oh, I don't know what m is. So I write it down as m. Don't worry. Then V is 8 n square. Half mv square. You don't know the value of m. Don't worry. Just leave it as m. You have to get over the reluctance to write an unknown as a letter. I say it one more time. You have, hey, listen, all listen, look up. You have to get over the reluctance to write down an unknown as a letter. Whether it is X, Y, Z, M, A, B, C, whatever it is, you have to get over it. Why am I saying this? Because we are very used to the way we solve problem sums in primary school. You know, they give you a bunch of sentences, they ask you to find something, right? You are very used to working like this. Where 3 times 2 equals to 6, then 6 minus 5 equals to 1. Whatever the working, and then the final will be answer equals to whatever intermediate answers you have, maybe 1 over 4. 1 over 4 times 3 equals to 3 over 4. You are very used to listing down all the different working, and then your final answer will just be the answer. Your final step will just give you the answer. You're very used to doing that. This process very taxing on your mind. You need to learn, you need to visualize, you need to know how to work backwards to get the unknown. Maybe it is the amount that Tom has. Then they give you a lot of information, right? Then you need to plus this times that, divide here, divide there, and then your final answer, wow, this times 3 equals to the answer. That's it. That is actually very difficult. Algebra solves all that problem. Algebra allows us to form an equation very easily. You just need to have the confidence to do it and to know what you're doing. Then after that, right, it's all your algebra steps, all the drill and practice that we have been doing. What you do on left hand side, you do on the right hand side. Just use that, you will be able to solve every single primary school problem sums very easily. Okay? But that requires you to be comfortable with writing down unknowns right at the first step. Typically, we don't do that in primary school mentors problem sums. They ask you to find the amount Tom has. You don't form an equation that Tom has, right? It's only at the end, then you finally, wow, Tom has something. In algebra, we are very used to writing unknowns in the first step already. 1 E equals to half M. Don't worry, M I don't know. V, 8 squared. Then we use our algebra to find out the value of M. What you do on one side, you do on the other side. So you have a choice already. You can multiply by 2 on both sides to get rid of the half. You can divide by half on both sides. You can. Or you can expand your 8 squared to become 64 divided by 2. 64 divided by 2 is 32M. So that's 160. So M must be 160 divided by 32. And we get 5. You need to wash your face? Need or no need? Or do you need to sit beside me? No need. So you can stay awake? Can? Can or cannot? Glenn, I'm talking to you. Can, huh? Yeah, sit beside me, cannot fall asleep one. Okay, next. Here we have exercise 6, a problem sum. The three angles of a triangle, x plus 10, 2x minus 50 respectively. Write down an equation in x. Write down an equation. What do all these three angles tell me? The three of them add up to be how much? No, these are angles. The three angles must add up to be 180 degrees. Okay, so we have x degrees plus x plus 10 degrees plus 2x minus 50 degrees equals to 180 degrees. Okay? Do you find it very troublesome to write all the degrees? Not difficult, not troublesome. So when you expand out, you need to write x degrees plus 10 degrees, then 2x degrees minus 50 degrees. You know that? Okay, if you know that, good. I just want you to be consistent. For me, very lazy. Remove all the degree over here.
Yes.
I can do that because I'm trying to find the value of x. X itself has a value, but when you put a unit to the value, it becomes a quantity. In physics, you learn about quantities, right? Your length, your mass, whatever it is. Okay? So let us... by the way, can I just have a quick check? Who has this first step? Like this. Equals to 180? Opposite. 180 equals to this plus this plus this. Yeah, same thing. I want all of you now to include this. On the right hand side, open bracket, draw open bracket. Everybody has to do it. open bracket, write down this symbol. Do you know what this symbol is? Angle, okay? Angle, sum, must write, this one must write. Angle sum of triangle. You must write this. Angle sum of triangle. This is angle sum of triangle. Lazy to spell triangle, so I just draw triangle. Okay, what does this mean? Why am I making you write this? Yeah, because I don't know where your 180 come from. The question didn't say 180, alright? No, they didn't mention anything about 180. You can't just write 180 and expect me to know where it came from. So you have to explain. Oh, the 180 came from the sum of the angles of a triangle. Yeah, it looks a bit weird lah. You can write in plain English. Sum of the angles of a triangle. But so many words, right? Very lazy. So this is the short form. Angle sum of triangle. Okay? Yes? Can. That will work also. But I think this is the shortest already lah. Angle sum of triangle. The less we write, right, the more time we have to think. Okay, so this is a must-have in your answer. So let us continue. X plus 2x, 4x. 10 minus 50 minus 40, that is 180. So 4x equals to 140. X will therefore be 140 divided by 4 to give us 35. Oh, sorry, wrong. Sorry, not. Very good. The ha over there. Okay, so it's 55. Okay, we are adding 40 to both sides.
And do you add the degree for the half?
Oh, wait. X itself is a number. X has a value of 55. Is X an angle? When I put a degree, then it becomes an angle. X itself is just a number. It has a numerical value of 55. Oh, what question do they want? Find the largest angle of the triangle. Yeah, we're not done yet. Do you think this is the largest angle, x? Or is it x plus 10 or is it 2x minus 50?
2x minus 8 plus 10.
Is it? How do we actually need to do the substitution into all of them to confirm? Or we just substitute two of them can already? Just the last two, right? Because I'm very sure that x plus 10 is more than x. Anyway, I already know the value of x. So, which is 55. Then I need to substitute inside. This gives me 65. And this is actually 60. Okay, so what is the largest angle now? 65. Okay, so you can show your working. X plus 10 equals to 55. Then the other one will be 2x minus 50 equals to the 60. Okay, so you write down largest angle equals to 65. Largest angle equals to 65 with a degree. Now it is important for you to put a degree. Can?
And then the other side.
So, do you think this is difficult, this particular question? Is it difficult? Can I have a show of hands? Difficulty 1 to 5. 5 being very difficult, I cannot do it. 1 being I can do it very easy. Where are you for this question? 1 to 5. This particular question. Show me your fingers. Wait. Show me your fingers. 5 being very difficult, I cannot do it by myself. Okay, thank you very much. Put our hands. You see what is this over here? You know what this means? This code over here. This means November 2011. Paper 1. Question 9 of O levels. So all those with a 1 and 2, right? You should be happy lah. You can do O level question already. Okay? So it can be done, yes?
You put 2x minus 5 instead of 2x minus 8.
2x minus 5?
Yeah, you put 2x minus 5. It's double with 2x minus 8. Where you go? Second last time.
Oh, sorry. So 110 minus 50, yeah, correct, thanks. Okay, next one. Three more questions. John took 3 hours to drive this particular distance. Wow, 3 hours to drive a distance. This question is setting us up for speed, isn't it? You've got the time, you've got distance. Just want to check, in primary school, how do you remember the relationship between distance, speed, and time? The triangle? Is it this triangle? What is on top? DST? Okay. Yeah, this works. I'm not sure. Is there anybody who has difficulty remembering something like this? Got difficulty? If you have difficulty, I can show you another method. Okay, class, listen. We share our ideas, then you choose the idea that helps you remember. Okay, it could be this triangle. I think this triangle is very useful. Another way is by remembering the units. Now, do you know the units of speed? Come on, you know the units of speed. Units of speed is kilometers per hour, right? Or it could be meters per second or whatever, right? Now, this sign over here, what does this slash over here mean? What does it mean? Divide. It is actually a division. So what we have is a distance divided by time. Can you see that? So as long as you remember the units for speed, you will forever know that speed is distance over time. Oh, what do you learn in physics? Speed is... What is the definition of speed in your physics? Really? Did they say it is distance over time? I can't remember already. Okay? But it's not the SI unit lah. Okay, regardless of what you use, I think this is quite useful. DST. Okay. And Mary took 40 minutes longer than John to drive X plus 11 kilometers. They both drove at the same average speed. Form an equation. They both drove at the same average speed. So what is John's average speed? So to find the speed, we cover the S. We have distance divided by time, yes? So what is the distance that John drove? 2x minus 7. What is the time that he used? Over 3. Okay, now pause over here. Pause. This is his average speed. What are the units over here? What are the units over here? Kilometer per hour. Are you very sure? Are you very, very sure? Or is it kilometers per minute? How are you sure? Yes, because the numerator has units of kilometers. And this is in hours, right? So the units will be kilometers divided by hour. Kilometer per hour. Okay. Whether you write it down or not, it does not matter. But I'll just write it down in pencil over here. Kilometer per hour. Okay, just to remind myself. Now next, what about Mary's speed? Mary's average speed is also distance divided by time, right? Distance. Okay, x plus 11. Oh, it's a different distance now. X plus 11. So scary. I don't know what x is. But don't worry. Okay, divided by the time. How long did she take? 40 minutes longer. 180 plus 40, okay. 220, yes?
Yeah, 220 minutes.
Okay. Do they drive at the same speed?
No.
Okay, did they drive at the same average speed? Yes or no? Yes? So does that mean that these two are the same?
No.
Why not?
Yes.
Are they the same? Sure they are the same? Meaning Okay, at this point you don't copy. Don't copy the next step that I'm writing. Are you saying that 2x minus 7 over 3 equals to x plus 11 over 220? Are you saying that they are the same now? Think. Same average speed, right? Okay, talk to your partner beside you. Are they really the same? Or you shy, you think about it by yourself? Okay, done? Do you have a conclusion? Are they the same? Are they the same? Who thinks they are the same? Who thinks they are different? Okay, majority actually thinks that they are different. So why are they? And I'll tell you the answer. Yeah, they are. Look at what I'm going to do. Look. They are not equal. So this slash over here means that they are not equal. But why? Okay, so yeah, I gave you the clue over here, right? This is kilometers per hour, whereas this is kilometers per minute. The units are different. So it is just like saying, I've got 1 kilogram versus 1,000 grams. Are they the same thing? Come on, are they the same thing? They are the same thing, right? But can I write 1 equals to 1,000? Cannot. Okay, because the units are different. So in order to write that they are the same, I have to ensure the units are the same. So now, what do you want to change? You want to change the 3 hours to become minutes, or do you want to change the 220 minutes to hours? 220 minutes to hours? Sure. Don't know why you all want the more difficult, but it's fine. Okay, 220 minutes into hours. Do you know how to change hours to minutes? I'm sorry, minutes to hours? Divided by 60. Okay, show you a useful method. Proportion. When you have, for example, 2 kilometers. For example, when you have 1,000 meters equals to 1 kilometer, for example, then you have a different length. For example, 38 meters. Okay, you want to change this to a kilometer. What do? Yeah, how? So, this is what I'm going to show you. I think it is a very useful concept, a very useful approach. Can be used from Sec 1 to Sec 4. Whenever you have proportion like this, you put them in this format, the same units on the left, and then the unknown on the right side, bottom right hand side to be precise. So to fill in this blank, all you need to know is to do a division over here. So 1 divided by 1,000, and then you do a multiplication over here. Okay? It always works for direct proportion. All your 3 apple cost $12, all can be used this way. 1 area costs how much can be used this way. So 1 over 1,000 times 38. So you get 0.038. Okay, you might know this as just simply divided by 1,000. Go ahead and use that if you want to. But I'm just showing you that with this, as long as you know one relationship, the very first one, you can do the rest. So, using your 220.
place lah, right?
So 60 minute equals to 1 hour. I want 220 minute. Will be 1 over 60 times 220. 1 divided by 60 times 220.
11 over 3.
Yes, 11 over 3 hours. Okay, question. Do you want to change this to hours and minutes, or do you want to leave it as hours? You want to leave it as hours, right? Because in the first place, John's average speed is already in kilometers per hour. So in my denominator, I want to change this to hour as well. So 220 minutes becomes 11 over 3 hours. So 11 over 3. And this is in hours. Now they are both having the same units. Do you see that? And now I can write 2x minus 7 over 3 equals to, denominator becomes 11 over 3. Now they are the same. And I have to solve. I'm not done yet. So fraction equals to fraction. Okay, you are already equipped with the skills to solve this type of question where you have fraction equal to fraction. But a little troublesome on the right hand side because I've got a tiny fraction inside another fraction. So maybe you want to consider rewriting this first. We don't like fraction in a fraction. So how do we change this to become just something over something? How do we do that? How do we simplify it? So you need to know, or I'll just put it on the right hand side again. X plus 11 over 3. This is the same as x plus 11 divided by 11 over 3. Right? Do you agree? They're the same. Our fraction is our division. Sorry, we should put the brackets over here. And dividing by a fraction is the same as multiplying by flipping the other fraction over. And we get 3 times of x plus 11 divided by 11. Okay? So this over here, very important skill to have. Very important skill. Because fraction divided by another fraction, we convert it to the multiplying by flip the fraction, and we end up with 3 times of x plus 11 over 11. So for those of you who are always looking for shortcuts, always trying to look out for a shortcut, is there a way for us to avoid doing all this? How do you use your calculator with x? So is there a way to avoid that? Yeah, turns out that there is. If you are looking for shortcuts. Now, I do not recommend shortcuts unless you know what you are doing. So if you can understand this step, only if you can understand these steps, then you listen to the shortcut. If you don't understand these steps, you do all of them over and over again until you understand. Then you use the shortcut. So where's the shortcut? The shortcut is, okay, let me remove all this. So this is our final answer. The shortcut is, are you ready? You just move the 3 up. Okay? 3 times of x plus 11 over 11. You have to know what you are doing before you can use this. And what are we doing? I showed it to you earlier on already. Don't know what you're doing, then it's very risky. Okay, so here we have, this is the same as, let me write the next step. 2x minus 7 over 3 equals to 3 times of x plus 11 over 11. Let's continue on this side. We are now ready to multiply. Because fraction equal to fraction. So we have 11 times of 2x minus 7 is the same as 3 times 3 times x plus 11. The step on the right. Any questions? Otherwise, I'm going to continue. Expand. 22x minus 77. That is 9x plus 99. Okay. Now, subtract 9x on both sides. Subtracting 9x leaves me with 13x on the left hand side. On the right hand side, I'm going to add 77. So I get 176. Thank you. I'm so ashamed of myself. 176. Because I was going to use the calculator. Okay, 176. Now x will therefore be 176 divided by 13. Or which is just 176 over 13. And I don't like this value. Okay? I was expecting to get a nice whole number, but I get 176 over 13. Let me just double check my work quickly, huh? 40 minutes longer. 3 hours. 0, 0. X plus 11. Yes? Okay, so x being 176 over 13, John drove 2x. So 2 times of 176 over 13 minus 7. This is the distance that he drove. And I get 261 over 13 kilometers. Okay, class, quiet. All look up. Same approach. We want to find the present age of Ken. So we let Ken's present age be x. That's what we want to find. That's why I'm going to let it be x. So Ken's present age is x. It is not enough to just say Ken's age is x. I want present because we're going to time travel already. 10 years ago, 10 years ago, Brian was twice as old as his brother. So 10 years ago, Brian was twice as old as his brother. Twice as old as x minus 10. Do you see this? Do you understand? You see, we don't have to spend a lot of time thinking how to formulate the working such that our final answer is just going to be x equals to something, or Ken's present age is something. We're going to work with x everywhere. It doesn't matter. And what else did they say? Now, the sum of their age is 44 years. Sum of age is 44, right? Present. The present sum of age is 44. Okay, let's think. How old is Ken at the moment today? How old is Ken? X. It is just x. And how old is the brother today? How old is the brother today? Is it this 2x minus 2 times x minus 10? For those of you who are saying 2x, why should it be 2x? Huh? That you mean this minus 10x? Sorry, this minus 10? Then you add another 10 up. So okay, wait. Let's talk about Brian's present age. Brian's present age. Okay, how much is this? If Brian was 2 times of x minus 10 10 years ago, how old is he now? Just 2x? Why? If 10 years ago, he was 2 times of x minus 10. Okay, now 2 times of x minus 10, then you need to plus 10, right? Plus 10. 2 times of x minus 10 plus 10. Okay, this is the key over here. Anybody needs explanation to get to this step? Because we all need to understand this before we can continue. Right? 10 years ago, he was 2 times of Ken's age. And Ken, 10 years ago, was x minus 10. Oh, now today, Brian has to be his age 10 years ago plus 10. And we can simplify this. This is actually 2x minus 20 plus 10, which is 2x minus 10. Today, Brian is 2x minus 10. Well, what else did they say? The sum of their age today. Present. Sum will be x plus 2x minus 10. We are adding both ages up. And they tell us that it is equal to 40. Oh, sorry, is it 40? 44, sorry. And they tell us that it is 44. And now it becomes solving an algebraic equation. So 3x minus 10, 44. 3x, 54. X, is it something? No. 54 divided by 3. 18. X equals to 18. Okay? Now, can I show